Welcome to this lesson. This is lesson 4 regarding to differentiation. Okay, in today's lesson, we will be dealing with differentiation involving trigonometry. Okay, as we take a look at this lesson, I would want you guys to visit our previous videos that we've done. Lesson 1, look at the lesson for part 2, for part 3, and then this is for part 4. Don't forget, this is Daniel Math Academy, whereby bringing these lessons to you. So you can follow us and then like us on Facebook at Daniel Math Academy, on Twitter, on Instagram at Daniel Math Academy, and also on YouTube at Daniel Math Academy. Alright, now quickly let's dive into this first problem as we're going to solve. This question says, if y is equals to x cos x, show that the y dx over dx is equals to 0 when x is equals to cot x. Alright, so let's begin by looking at this. So here we have that y is equal to x cos x. So here we could assume that this, or we want to agree that this is this function is a product rule. Okay, so where this is our u and this is our v, right? So we're going to treat this as such. So now we have that our product rule states a product rule. I'm going to write that here. So our product rule states that dy upon dx is equals to u dv over dx plus v du upon dx. Okay, so this is basically what the product rule states. So now let us go ahead to solve that. It means that u is equals to x, then therefore du upon, let's go ahead to, once you first of all assume that this is that, so you equate what you've assumed, then you differentiate that with respect to x, and this will give us 1. Okay, this will give us 1. Now we've gotten that. Now we'll go ahead again, and then we'll find we're going to go ahead again to now look at the next one. We have that v is equals to cos x, then it therefore means that dv upon dx will give us minus sine x, because if we differentiate cos x, you get minus sine. If you differentiate sine, you get cos. Alright, so this is what we have here. Now then we're going to plug all of this into our equation. So I will finally have that dy upon dx, will give me my u is x, so x into, or x times my dv upon dx is minus sine x. Okay, plus now my v is what, cos x times 1. Okay, du upon dx, that is 1. All right, so this is what I have. So if I go ahead, this gives me that dy upon dx is equals to x times minus sine will give you minus x sine x, and then this will give me plus cos x. Okay, so this can also be written as cos x minus, minus x sine x. Okay, so this is all right. So, and take note, so this is dy dx. Now, but we are told here that we should show that dy dx is equal to 0 when x is equal to cot. So let's equate this to 0. These are dy dx, so we're going to equate it to 0. All right, so what we have is that here is, from here we could say that cos x minus x sine x is equals to 0. So take this over here, we'll have that cos x. So we'll have it that x sine x is equal to cos x. Alright, if we go on further from here, you agree with me that we'll have that x is equals to x. We'll have it that x is equals to cos x divided by sine x. Okay, now let us know that cos x over sine x is equals to cot x, is equals to cot x. Okay, so that's what we have. Now remember that sine x over cos x is equals to tan x. Okay, and then that cot x is equals to 1 over tan x. So this is what we have. All right, so we've proven very clearly that x is equals to cot x from this mathematical expression. All right guys, so that's what we have here. All right, I hope you understand. You can pause the video and then go through it again until you've gained mastery. Let's look at example 2. All right, now example 2 here says, that is example, that's question 35. Question 35 here say the distance x traveled by a body in time t is given by the relation s is equals to t plus 1 over 1 plus t. Find the velocity of the point t is equal to 2. Alright, so what we'll have to do here is first of all to write out our formula that s is equal to t plus 1 over 1 plus t. So this is what we have now. So we could go ahead to transform this, and this will give us that s is equals to t, s is equals to t, s is equals to t plus, then for 1 over this will give us 1 plus t all raised to power minus 1. 1 plus t all raised to power minus 1. Okay, so this is what we have here. Now this way we can now go ahead to differentiate because we've linearized everything. All right, so we are asked to find the velocity, but recall that velocity is equals to the derivative of distance with respect to time. Okay, so when we differentiate s here with respect to time, that will give us the velocity of that equation, of the body, of the motion traveled by the body. So let's differentiate this. So that means that if we differentiate this, we will get that the s over dt is equal to differentiate t, we get 1. Differentiate t, we get 1. Okay, then plus, if we differentiate this will give us minus 1 times 1 plus t all raised to power minus 1 minus 1. Okay, so that's what we have here. And then we could go ahead to say that the s over dt is equals to 1. Then here we have minus 1 plus t raised to power minus 2. Alright, so this is what we have. Now we could go ahead to simplify this further, that the s over dt is equals to 1. Then this will give us minus, and this point will give us 1 all over t, 1 all over 1 plus t raised to power 2. Alright, so this is same thing as writing this. Okay, this is same thing as writing this. So this is the answer to this in particular question here, guys. Alright, so that's what we've done so far. So I hope you guys understand. And then so this is where we've come now, and at this point, and then we could go ahead to find the second part. We're asked to find t when we have to find the expression when t is equals to 2. So if we do that, so now say when t is equals to 2, when t is equals to 2, so this gives us that the s over This gives us that the s over the t is equals to 1 minus 1 all over 1 plus 2 all raised to the power 2. Okay, so this will give us 1 minus 1 all over 1 plus 2 is 3, 3 raised to the power 2 is 9. Okay, so this is 1 plus 9, so when finally have that, therefore the s over the t is equals to 9 times 1 9, 9 minus 1 is 8, and the answer is 8 over 9. So our final answer here is that we have 8 all over 9 as our answer. Okay, so this is the answer to this question when we substitute t equals to 2 into the equation. Alright, so this is what we have, guys. So thank you. I hope you understand the lesson. Let's look at the next question. Alright, here in our question 3, we're asked to find the y dx for the given expression. Y is equals to 3 sine 3x all upon x. Alright, so now first of all, we have to deal with this. Up here in the numerator, we have y is equals to 3 sine 3x all over x. Alright, so here we could note that our numerator is a product rule, so we're going to solve this using a different method. So let's assume, right, so basically what we need to do is to treat this as a function, and then when we're done, bring it back to here. So I'm going to assume that let u is equals to 3 sine 3x. Okay, now why u is equals to 3 sine 3x. Now from here I'm also going to say that, so if u is equals to this, I'm also going to say that let me call this to be uv, and then let me say w. So w, let me call this w is equals to sine 3x. Okay, now so what this is going to give me here is that I'm breaking this part, okay, into two functions. So if this is this, then it therefore means that the w over the x is going to give me 3, okay, cos 3x. But differentiate this with respect to x, I'm going to have 3 cos 3x. And then let me come back here and also know that what I have here is that since I have u is equal to 3 sine 3x, then definitely means that, okay, now so I could use that method, all right, or probably I could just go ahead to let's just go ahead to say that if we differentiate this, all right, so going on the second part, I'm going to also say that since, or most still, let me use another approach to solve this, making it more simpler and more than making it complicated. All right, so now in this case, this is my u, and this is my v. Okay, let's use our product. Our quotient rule says that dy upon dx is equal to dy upon dx. Okay, here is equal to dy upon dx is equals to u dv upon dx minus v du upon dx all upon v squared. Okay, so this is what we have. Okay, so I'm going to keep this here. All right, now so let's go ahead to apply that. So I have from here that dy upon dx is equals to, my u is what? My u is 3 sine 3x, then my dv upon dx, if I differentiate x, I'll get 1. Okay, now so that's what I will get. I'll get 1. So we've done this over back in quotient through, so just applying this. Okay, now then minus, I have my v here is x into my du dx. Okay, so if I differentiate this, now look up, the differential of sine 3x is equals to, I already have 3 here, this is 3 times the differential of sine 3x is going to give me 3 cos 3x. Okay, so this is what I have. Now take note, the derivative of sine 3x is equals to, the function of x here is 3x, so 3 comes out, I have 3, then if you differentiate sine you have cos, and then finally we have a cos 3x all back. Now all of this is going to be divided by my v, which is x, so this is x square based on our formula. Alright, so if I go forward, this gives me that dy over dx is equal to, this will give me 3 sine 3x minus 3 sine 3x, okay, minus if this would give me 9, so this will give me 9x cos 3x, okay, 9x cos 3x, and all of this is divided by x square. Alright, so automatically this happens to be the answer to this question. Alright, so this happens to be the answer to this question. Alright, so stop here, this is our answer. Alright, so guys, hope you understand this. So just take it from the method, from what you've done so far, you just probably see. So take it again, we assume this to be u and we denote this to be v. Okay, so once we've done that, we go ahead to apply our formula for quotient through, that dy upon the x is equals to u dv over the x minus v du upon the x, or v square all over v square. So we'll go ahead to write our u. Our u is 3 sine 3x, which is this, and then the derivative of v, which is x. If you differentiate x, you get 1 minus, and then our v is x, and if you differentiate 3 sine 3x, we get 9 cos x. So once you do your algebra, you end up having this. Okay, so that's what we'll have here as our answer. Let's look at the next question as we continue in the series of this lesson. Alright, so for this question, alright, we're just going to apply same principle. So I'm going to revamp this. So let's look up this. I'm going to refer this to be u, and then I'm going to refer this to be v. Alright, so we're going to apply the product rule to solve this question. So therefore, now let's begin. The product rule says that dy over dx is equals to u dv over dx plus v du upon dx. Alright, so in this case, I'm going to use this, means that u is equals to 2 sine 2x. Now then du upon dx will give us, so if you differentiate sine 2x, you get 2. Okay, so this 2 is already there, so we'll have this, and then if we differentiate this, it will give us, differentiate sine 2x, we get 2 cos 2x. Okay, this automatically will give us 4 cos 2x. Right, 4 cos 2x. So that's what we'll have here. Okay, now also likewise, if we differentiate for v is equals to cos 3x. Okay, therefore means that dv upon d, therefore means to dv upon dx is equals to minus, if you differentiate cos, you have minus sine. Alright, so you have minus sine, then if you differentiate cos 3x, you have minus 3 sine 3x. So this is what we have, minus 3 sine 3x. So we'll take all of this back to substitute them into this point. into this normal equation, we will finally have here that dy upon dx is equal to, so u is 2 sine x, 2 sine 2x as u, and then into our v, the v dx is minus 3, the v dx is minus 3 sine 3x. Okay, so this we'll have, and then we'll have plus, okay, our v here is cos 3x. So I'll come back to write this, continue this down here. So our v is cos 3x, and then what I have for my du dx, is 4 cos 2x. Okay, so this is what I have. So I can go ahead now to write that my dy over my dx is equal to, alright, so this will give me, so if I open this bracket here, if I write everything out, it's going to give me 2 sine 2x times minus 3 sine 3x. Then here I have plus, and this will give me cos 3x into 4 cos 2x. Okay, so this is what I have, 4 cos 2x. This is what I have. Okay, so I will have that finally my dy upon dx is equal to this. If I open up this, will give me minus 6. Okay, so now let's go ahead and look at, so what I'm going to have here is I'm going to have minus 6. Okay, this will give me minus 6, okay, sine 2x sine 3x, okay, and then I have plus, here will give me 4 cos 2x cos 3x. So this is my answer to this question. Alright, but I could decide to rewrite this in another form. I can say this is equals to, so instead of making minus signs to lead the equation, I'm going to use this, I'm going to reverse it and bring this one here. So I will have 4 cos 2x cos 3x, then I have minus 6 sine 2x sine 3x. So this automatically becomes the answer to this question, Alright, so this is my answer to this question. Alright guys, so I hope you understand, and that is how we've come to the end of this solution. Alright, so let's look at the next question. Now the next question has basically been very similar to this. Alright, so it gives us the same thing. We'll have that y is equals to x sine square x. Find the y dx. So we're going to do the same thing. We're going to say that let u is equals to x. So therefore du upon dx will be equal to 1. Alright, so remember that in our normal method, this is equals to u and this is equals to v. Alright, so now also I'm going to do this. So also I'm also going to say that let v is equals to sine square x, and if I say that sine square x, then it's going to mean that dv upon dx is equals to, so what would this give me? This will give me 2. So this will give me 2. Okay, this will give me 2 sine x cos x. Now the reason for this, let's look up please. The reason for this is it's going to be 2 times just like we're using our power rule. Okay, 2 times sine x, so it becomes 2 sine x. Then if you differentiate sine x, you get cos x. So it's 2 times sine x, 2 times sine x, then you differentiate sine x, you get cos x. All right, so that's what we'll have. Now then we're gonna use that now to plug into our formula to find that dy upon dx is equals to u dv over dx plus v du upon dx. Alright, so this is our product rule. Then if we go ahead to solve that, we'll have that dy upon dx is equal to our u is what? Our u is x, and then our dv dx is 2 sine x cos x, and then we'll have this plus v in this case is equals to sine square x into du dv is equals to 1. So go further, we'll have here that dy upon dx is equal to expand this, I have 2x sine x cos x, and then I have plus, then I have plus sine square x. Okay, then I have plus sine square x. Right, so go down again, we would have that dy upon dx, we have that dy all over dx is equal to this. So right, so we could write this to give us sine square x plus 2 and square x plus 2 x sine x and then cos x. Alright, so factorize, we'll go ahead to have that this gives us, so we'll have sine here, we'll have sine here, so this will give us sine x into sine x plus 2x cos x. This is what we have, alright, as our final solution to this question. Alright guys, so this is the answer to this question. I hope you guys understand from what we've done so far. I hope you guys understand from what we've done so far. So just remember that you must always practice and practice for you to get to your destination. So that is it for this class. Alright, let's quickly take a look at the next question. Question 39. Don't forget, it is Daniel Maths Academy bringing you these lessons. Don't forget to stop to go to our YouTube channels and then subscribe and follow our videos. Turn on the notification bell for next videos that we're going to bring up as we bring more lessons to you. Follow us on our Facebook channel at Daniel Maths Academy. Likewise, follow us on our Instagram channel and Instagram page at also Daniel Academy. Alright guys, thank you. See you in the next lesson. Next problem. Right, so let's go to the next lesson. And for this, same thing we're going to do here. Okay, so we apply the same method here. So we present this as our v, present this as our v, as our u, alright, and this is our v. Okay, so u is equals to 1 plus x, then this means that du upon dx is equals to 1, and then likewise if v is equals to cos 3 is cos is about 3x, then it therefore means that dv upon dx is going to give us, so what we do here is 3 times cos x, so this gives us 3 cos x, and then what is the derivative of cos x? That gives us minus sine x, so minus sine x. Alright, so if we do that, what that will give us is minus 3 cos x minus 3, that gives us minus 3 cos x and then sine x. Okay, so dv over dx is equals to minus 3 cos x sine x. Okay, or whatever method you want to use, minus 3 cos x sine x. Okay, so now let's go ahead and plug in the formula for our product rule. The product rule says that dy, the derivative dy upon dx. Okay, so basically what our product rule says here is that if y is equals to uv, okay, now it therefore means that dy upon dx is equal to, so that will give us u differentiate, write u differentiate v with respect to x, plus write v and differentiate u with respect to dx. So this is what we have. Alright, if I apply that, we now have that dy upon dx is now going to give us, so what this will give us is that my u is 1 plus x, this is going to be 1 plus x, okay, times dv over dx. So that gives me minus 3 cos x sine x, okay, then plus and plus my v is 1, my v is cos cube x into my du dx is equals to 1. Okay, so therefore means that dy over dx is going to give me, multiply this out, it gives me minus 3 bracket 1 plus x into cos x sine x plus this gives me cos x. Alright, so this is what I have. Now I could factor, I could go further to get that dy upon dx is equal to cos x into, that gives me cos x into 1 minus 3 into 1 plus x sine x. Okay, so this is what we have as our answer to this question. Okay, what was the answer to this question? Alright guys, so I hope you understand from what we've done so far. Alright, so that is what we have, and then we'll keep going by solving more problems. Okay, so let's look at this next question. The question says find the y upon the x when y is equals to 1 plus sine x over 1 plus cos x. So what we do, we use quotient rule. So say using, so here I'll just say using quotient rule. Quotient rule says that, so what it says here is that if y is equals to u all over v, then therefore means that dy over dx is equals to u dv over dx minus v du over dx, all of this being divided by v squared. So this is basically what quotient rule says. Okay, now so you write the upper one, the numerator, differentiate the denominator, and then you write the denominator here and then differentiate the numerator all over the denominator square. So it therefore means that from this question that u is equals to 1 plus sine x. Okay, if this is this, then therefore means that du over dx is equals to what? Differentiate 1, you have 0, differentiate sine x, you have cos x, so this gives us cos x. Alright, likewise, it therefore means that v is equals to what? 1 plus cos x. So this means that dv over dx will give us, differentiate 1, you have 0, differentiate cos x, you have minus sine x. Okay, so this is basically what we have. So it therefore means that dy over dx is equal to, so we plug in the formula here, what we have is that my u here is what? 1 plus my u, okay, is 1 plus, and u is 1 plus sine x. Okay, so 1 plus sine x, all right, times my the v dx is equals to minus sine x. Okay, and all of this minus, all of this is minus, all of this minus. Oh, have v, our v in this equation is 1 plus cos x. All of this times my du dx, du dx is equals to cos x, cos x. Okay, so all of this being divided by, oh, have, what's my v? 1 plus cos x all square. So if we go ahead, I have that my dy over my dx is equals to, so this times this, if I open up this bracket, what I'm going to have here is that I have minus sine x. What I'm going to have here is that I have, this times this gives me minus sine x plus, sorry, minus sine square x. Okay, and that's what I have there. And then for here I have, if I open this up, this will give me minus, and then minus, then I'm still going to have this bracket. So minus, if I expand this, I'm going to have cos x, and then I have plus cos square x. And all of this is being divided by, all of this is being divided by, so this will give me 1 plus cos x all square. Alright, so this is what we have. Now let's quickly turn to the next page, okay, probably so that we could continue based on this page that we have here. So if I turn over to the next page, I have that is what I have. So if I go ahead to solve from what I already have here, I will have that dy, over dx is equals to, so if I add the expression, this gives me minus sine x minus sine x minus sine square x. Okay, then if I open up this bracket, this gives me minus cos x, and this gives me minus cos square x. Okay, and all of this is being divided, okay, by, we have 1 plus cos x all square. If I go further, this will give me that dy over dx is equal to, dy over dx is equal to, so I'll take like terms here. So you can see here I have sine x, and then here I have cos x. So this will give me minus sine x minus cos x. Okay, and this gives me minus sine square x, and this gives me minus cos square x. If I go further from there, this will give me all divided by, this is all divided by 1 plus cos x all square. If I take it further, I will have dy upon dx is equal to, so this will give me minus into, this will be sine x, and then I have plus cos x. Okay, here also I have minus into, I have sine square x, and then I have plus cos square x, and then all of this is being divided by 1 plus cos x all square. Alright, so from here I could still go further. This will give me, so take note from here, take note that in trig ratio, that sine square x plus cos square x is equals to 1. Okay, sine square x plus cos square x equals to 1. So this will be substituted by 1. So that will give me that dy over dx is equals to minus into sine x plus cos x, and then this will give me what? And this will give me minus 1, okay, minus 1, all of this minus 1, and then all of this is being divided by what? So minus 1, and then all of this is being divided, right, by 1 plus cos x, and then all square. So I could go further to simplify this. As if I open up bracket, I can have that this gives me minus sine x minus cos x minus 1. All of this divided by all of this is being divided, okay, by 1 plus cos x all square. Alright, so basically I can still go further from here. Alright, okay, let's write it up here. So let's write it, then I can still go further, and then this will give me, this will probably, let me just take this up here and write this here. So this will, okay, let's, alright, so if we go further from here, this gives us that dy over dx is equals to minus, so factor out minus sine, and this will give us sine x plus cos x plus 1, all of this being divided by with all of this being divided, right, by 1 plus cos x all square. So this happens to be our final answer, alright, to this question. So this is our final answer, guys. Alright, so please take note of this. Alright, so don't forget that we said that practice, okay, is always a good point to start in whatever you want to do. So once you keep on practicing, you discover that you master the game. So master the game. Don't forget, this lesson is brought to you by Daniel Maths Academy. Alright, so like our videos, follow our pages on social media, and then comment, share videos to friends and loved ones, and then you can also subscribe, okay, to get our paid lessons. You can subscribe to get any topic that you want. Just let us know, and then we'll be there right away serving you. Okay, guys, so now let's begin. Let's look at the next question quickly as we begin to wrap up in this section of solving differentiation with trigonometric function. Now this question here tells us that y is equal to tan x minus x all over tan x plus x. In the same similar way, so this is equation of function. So where this is our u, and then this other point is our v. So this numerator is our u, and then our denominator is our v. Okay, so applying, we said earlier that if y is equals to, if y is a function that is written as u over v, then dy upon dx, which is the differentiation of this equation, is equal to u dv over dx minus v du over dx, and then all of this being divided by with v square, alright. So this is the equation backing, this is the rule, alright, backing this. So I want us to understand this very well. Now I will go ahead to begin to solve. Okay, so from here we have that if u is equals to tan x minus x, then therefore means that du over dx is equals to, so if you differentiate tan x, what do we have? We have sec square x. The differentiation differential of tan x gives us sec square x, and then differentiation of x is equals to -1. So this is what we have. And then likewise, in the same vein, if we differentiate, in the same vein, if v is equals to tan x plus x, then dv all over the x is equals to dv over the x, okay, here is equals to sec square x, okay, plus 1. Alright, so that's what we have. Now if we combine everything together to substitute to here, we'll have it that dy all over the x is equals to, what's my u? My u is tan x minus 1 minus, my u is tan x minus x, and then my dv dx is equals to sec square x plus 1, okay, sec square x plus 1, and then here I have minus, and then v is equals to tan x plus x, and then I have this into my du dx is equals to sec square x minus 1. Okay, so all of this is being divided by v. My v is tan x plus x, or tan x plus x, all raised to power 2. So dy dx can further be broken down. dy dx can further be broken down to give me. Alright guys, but now let us know that, so let's do something here again just to give us some trig functions. Okay, so what I want to make us understand, I want us to note that sec square x minus 1 is equal to tan square x. Okay, so that means everything in du is equals to, so we can see that this, so we can say here that this is equals to du over dx. All right, so let's take a look at that. And then also I'm also still going to let us know that for dv over dx is equals to sec square x plus 1. All right, so if this is this, let's call this, so this is what we have. Now let's take this over to the next page. All right, so I would like to just clear that also from here, if sec square x minus 1 equals to tan square x, then it therefore means that sec square, it means that from here, so let's call this equation 1, let me call this equation 2. It means that okay, so it means that, let's call this equation 1, let's call this equation, it means that from equation 1 I can have that sec square x is equals to 1 plus tan square x. Okay, so this is what we have for sec square x. All right, so if that's what we have, then if I substitute this, let's call this equation 3. If I substitute equation 3 into equation 2, we have that dv over dx is equals to sec square x plus everything about, okay, plus 1. All right, so and then we said that sec square x, okay, is equals to 1 plus tan square theta, So this will give us that this will be 1 plus tan square x plus 1. Alright, so dv over dx is this, and this can also be written that dv over dx is equals to tan square x plus 2. Alright, so this is what we have for our dv, okay, over dx, and then also we'll have that our our du upon dx is equals to tan x squared. So our du over dx is equals to tan square x. Alright, so this is what we have. Now we can go ahead and begin to what? Substitute. So let's take it over down to the next. So let's come back here and then try to substitute that into this equation. So by doing that, I'm going to have that this will give me that dy over dx is equals to tan x minus x, and then into here what I will have here in place of, don't forget that what I have here is that this formula is my dv over dx, okay? dv over dx, that's what I have here. And what's my dv over dx is tan square x plus 2. So this is tan square x plus 2, and then minus, here I have tan x plus x, and here I have into, what I have here is tan square x, which is my du dx, so tan square x. So this is what I have here, and all of this is being divided, okay, by, all of this is being divided, alright, by tan x plus x raised to power 2. So if I go further, this gives me dy over dx is equal to, so I'm going to expand this. So on this, I'm still going to still have tan x minus x into tan square x plus 2, and then here I will have minus, so this times this will give me this times this, so let I have minus, and then let me have this, that time this times this will give me tan cube raised to power x, and then plus I have x tan square raised to power x. Okay, so this is what I have, and all of this is being divided, and all of this is being divided by tan x plus 2 or raised to power 2. Alright, so if I go further from here, I have that dy over dx is equals to, alright, so if I go on from here, now what I'm going to have from this is that this gives me, so I'm going to expand this, so this will give me tan times tan x times tan x squared, tan square x will give me, so this will give me tan cube raised to power 3, this will give me tan cube raised to power 3, and then tan times plus 2, that will give me plus 2 tan x, then I'm done with this, so it was this times this, and then this times this. Now I'm going to have this times this is going to give me minus x tan square x, and this will give me minus, and then x, and then this will give me, and then this will give me this minus, this will give me minus 2x. Okay, so this is what I have, and then all of this is going into, so if I open this up, this will give me minus tan cube x, and then this will give me minus x tan square x, and all of this is divided by tan x plus 2, tan x plus x, sorry, so take note please, this is x please, this is x. Okay, let's do that please, let's correct that please. This is x please, and this is x please, let's correct that. This is x, okay, or square. So let's continue solving. So what we'll have from here is to begin to take like terms. So I'll have that dy upon dx, dy upon dx is equals to, so if I do that properly, so we'll see that tan cube x will cancel tan cube x, and then again what I have here is that I have 2, so I have 2 tan x, then minus x tan square, minus x tan square x minus x tan square. This will give me minus 2x tan square x, and then I have minus 2x. All of this is being divided by tan x plus x whole square. Okay, so I have dy over dx is equals to, so let me write this in ascending order. So I'm going to get, so what I'm going to get here is that I will have 2 the x tan, so 2x multiply all three by negative signs. I'm going to have 2x tan square x. Then what I'm going to have here, I'm going to have minus multiply that, so this give me tan x, and then minus times here, this give me plus, so you have 2x. Okay, so just to ensure that I leave that this is being led by the highest power of x. Okay, so what I did here was to multiply throughout, so multiply, so what I did here, please, what I did here was to multiply by minus by negative. Okay, so that's what I did here now, and then all of this that I've done is being still divided by, all of this is being still divided, okay, by tan x plus x all square. So this goes on to give me to y on the x is equals to, I can factor here, alright, so if I factor here, I have 2 being factored, and then I have x tan square x minus tan x, and then I have plus x, okay, and then all of this is being divided by tan x plus x all square. So this can be further pushed down to dy over dx is equals to, so what I'm going to have here is that I'm going to factor x, so there's x here, okay, so this is going to be 2 into x, and then into tan square x, okay, plus 1, so x is here, x is here, so I'm factoring plus 1, okay, and then here I now push this minus tan x, so this is minus tan x, okay, and then all of this is bracket close, then dividing all of that by tan x plus x all square. So let me write that again down here, so that I'll have that dy over dx is equals to 2 into x into tan square x plus 1 minus tan x or bracket close, and then this is, all of this is being divided by tan x plus x all square. So let's take this up down to next page. Okay, so this is what I have. Now if I go further, I have that dy upon dx is equals to 2 into x, and then don't forget that here, so this will give me tan square x plus 1 is equals to sec square x, okay, and then have minus tan x here, okay, then all of this is being divided by, all of this is being divided, okay, here by tan x plus x all raised to power 2. Okay, so what I basically have, therefore finally, that dy over dx is equals to 2 into x sec square x minus tan x. All of this divide by tan x plus x all raised to power 2. So this happens to be the answer to this question. This happens to be the answer to this particular question that we have here. Alright guys, so this is the answer to this question. Thank you guys for staying with us throughout this lesson. Alright, so let's see in the next question. Alright, see you in the next topic as we continue this lesson. Alright, so let's do this question number 42. We are solving question number 42. Right, so let's look at this. So here we have that same formula we're going to use as quotient rule also. So these are u and also these are v. Alright, so don't forget that dy over dx is equals to u dv over dx minus v du over dx, and then all of that is being divided by our formula here, which is v squared. So don't forget that this is the formula for quotient was rule for equation where we have that y is equals to u all over v. So in this case, my u is equal to sine 3x. Therefore, du all over dx is equals to, so sine 3x, this will give me 3 cos, so this will give me 3 cos 3x. Alright, so my v, if my v is also equals to 1 minus x raised to power 3, okay, and therefore means that my du and my dv all upon my dx is equal to 3 into, okay, 3 into minus 1, because if you differentiate minus x, you get minus 1. 3 into minus 1 times 1 minus x raised to power 3 minus 1, which is equals to 2. Okay, minus 3 minus 1, which is equals to 2. So if I go further here, I will have it that my dv over dx is equals to minus 3 into 1 minus x all raised to power 2. So that's what I have for the differential of that. Now let's go ahead to quickly substitute. So I have that my dy all over my dx, my dy over my dx is equals to, my u is sine 3x into my dv over dx, that gives me minus 3 into 1 minus x raised to power 2 bracket square, and then I have minus into v is 1 minus x raised to power 3 times, and then my du over dx, that is 3 cos 3x. Okay, this is what I have, all of this being divided, okay, by my v, which is 1 minus x raised to power 3, and then all of this is raised to power 2. So this is what we have. Now we'll go ahead, we'll have that dy over dx is equal to dy, we'll have here that dy over dx is equal to, so if we open up this bracket, so this will give me minus, minus 3 sine 3x into 1 minus x raised to power 2, then minus, okay, so basically what I'm going to have in the second part, okay, of this equation is 3, and it gives me 3 into 1 minus x raised to power 3 into cos 3x, and all of this is being divided by, we have here to be 1 minus x raised to power 3, and then all of this is raised to power, and then all of this is raised to power of 2. Alright, so let's take this to the next page. So we have that dy over dx is equals to, multiplied throughout by minus sign, we have that this will give us 3 sine 3x, and then we have 1 minus x all square, and then we'll have plus 3 into 1 minus x raised to the power 3 cos 3x. All of this is being divided. All of this is being divided, okay, by 1 minus x raised to the power 3 raised to the power 2. So dy over dx is equals to, so let's look at for, so looking for a common factor, we could see here that there's 3 here and then there's 3 here, so 3 is a factor. Then also we have 3 as a factor. Here we'll have 1 minus x raised to the power 2, so we see that also as being a common factor, minus x raised to the power 2, and then so there's nothing here again, so we just have to put this into a bracket. So this gives us nothing left than just sine 3x, and then this gives us plus just nothing again left but having, okay, so here we'll have, we brought this and then both of this, so we'll have sine 3x left, and then we'll have the same thing here. We'll have 1 minus x raised to the power just 1, and then here we'll have cos 3x. Okay, so this is what we'll have, and then we'll have all of this being divided also by 1. Okay, so if we expand this, this will give us, if we expand this, that will give us 1 minus x raised to the power 6. Okay, so that will give us 1 minus x raised to the power of 6. So if we move on from there, this will give us, so if we move on from there, we could simplify this to give us that dy over dx is going to give us, so here we could get rid of this, so this is common, so this could go here, all right, 1, this will go here, so we'll have left is 4. We have 1 minus x raised to the power 4 left, so this will give us 3 into, so this gives us 3, this gives us 3, and then into, so what we'll have here, we could write this, okay, and this could still give us sine 3x. Okay, now okay, let's write this other way to give us cos 3x into 1 minus x, cos 3x into 1 minus x, all of this plus sine, all of this plus sine 3x, bracket close, and then we have this, all of this being divided by 1 minus x raised to the power of 4. So this happens to be our final answer to this question. All right, so this happens to be our final answer. Okay, so it's our answer. All right, so guys, so this is the answer to this question. I hope you guys understand. It's probably a tedious one, but then same method we just followed through to deal with this this similar question. So we started from here, question 42. All right, then move from here, okay, to down to this point, and then from this point. So this is just the path for this particular question. All right, guys, so and then finally we're going to look at the last but not the least question here that we'll be dealing with today. All right, guys, so let's quickly solve this part, and I'm going to leave you guys with lots of practice exercises. Okay, all right, so from this question we have, find the 2y over the x squared when y is equal to x minus 1x bracket upon x minus 2, and then all of this is being divided by x, and determine the value of y2, the 2y over the x squared when the y is equal to 0. So if we have this, so I'm going to expand this, y is equal to x minus 1 and then x minus 2, and then all of this is over this. This can go further to write that y is equal to, so if I expand these two terms, I will have that this will give me, so let me quickly do this here so we could see how that is done. So I'm just going to do a bracket here, so x minus 2 and x minus, so what I have here, okay, please take note, x minus 1 and x minus 2. Okay, so this times this gives us s square. This times this gives us, so this times this gives us minus 2x. This times this gives us minus x. This time this gives us plus 2. This will be s squared minus 3x and plus 2. So this is what we have. So this will give us y is equals to x squared minus 3x and then plus 2. All of this is divided by x. Okay, so we'll have our, this is, in this case, this is our u and this is our v. So if I apply a formula that dy over dx is equals to u dv over dx minus v du over dx, and all of this is being divided, by v squared. So this gives me that dy upon dx is equal to u, in this case, alright, is equals to this. So my u is equals to x squared minus 3x plus 2, and all of this multiplied by dv. So my dv, if I differentiate v, and that gives me 1, and then minus my v is x. If I differentiate this gives me, the u gives me 2x minus 3. Okay, so that's what I have here, and then this is all divided by x all square. So we can go further to write this to be dy over dx is equal to, this will give me x squared minus 3x plus 2, and then if I expand this will give me minus 2x squared, and that gives me plus 3x, and all of this is being divided, by x squared. So this function will give me dy over dx is equal to, so let me check, the like terms to cancel off, or anything to take, like terms, so minus 3 plus 3 is gone. So what I have left is x squared. Okay, so what I have left there is s squared minus this, that will give me, so this, so I have 2 minus x squared all upon x squared, all upon, please, and this is all upon x squared. So x squared minus 2s squared, that gives me minus s squared, so that's what I have here, minus s squared, then have 2 here. So if I go ahead to simplify this, so therefore dy over dx is equals to 2 minus x, 2 minus x, and then all divided by x squared. So this is the answer to this question. Alright guys, we'll stop here. So far in this video, we've discussed on the different methods for solving quotient rule. We've discussed how to solve product rule, and in the just concluded video, we discussed on how we could solve questions related to trigonometric functions, okay, involving differentiation involving trigonometric functions that was just done in this class so previously. Okay, now so I'm going to leave you guys with some practice exercises that you're going to solve and then to master your hand properly. Alright guys, so let's just quickly remember that this question asked us to find the 2y over the x squared. So let's complete this question now. And what we're going to do here is to differentiate this again. Before differentiate this again, I can further simplify. I can say this can be simplified. So therefore, I can therefore say that this can be simplified further, that dy over dx is equals to 2 over s squared minus x squared over x squared. So this is the same thing as saying 2 over x squared and then minus 1. Right, so this is what we'll have. And then I can also write that dy over dx can also be written as 2x raised to minus 2 or minus 1. So this is what we have. Now, then it therefore means that the second differential dy square over the x square is going to be the derivative of this. So this will give us 2 times, then this will give us minus 2 x raised to power minus 2 minus 1 is minus 3. Okay, so take note please. Let me do this properly. This gives us minus 3. Okay, so then differentiation of a constant is equals to 0. So this minus 0, you can have it that the 2y over the x square is equals to this give us minus 4x raised to the power what? Minus 3. Minus 4x raised to the power of minus 3. So this can also be written that the 2y over the x square is equals to, this gives us minus 4 all upon x raised to the power 3. So this is what we have, alright? Now don't forget that we were asked in the question, determine the value of the 2y when dy dx is equal to 0. So now going to solve that, we already have that when dy over dx is equal to 0. So I would want to just probably do this here. That's it. I could just want to do this here when I would say if dy over dx is equal to 0, then it means that, then therefore that means that 2 minus x square all upon x square is equal to 0. This will mean that 2 minus x square is equals to 0. Alright, then that will give us that x square is equals to 2. Therefore x is equals to plus minus square root of 2. Okay, so as typical and as simple as that. So this is the value of x in the equation that we asked to solve. Alright, so that is just that. Now, so let's go ahead and then we'll have this practice exercise here for you guys to use. Alright, now the second one says, okay, second part exercise says that when y is equals to cos 1 all over x. So find this, then number 3, and then for number 3 we'll have that y is equals to x squared plus 1 whole bracket into square root of 1 minus x squared. So 1 minus x squared, so 1 minus square root of x squared. So this is what we have for question 3. So take your time and solve this, and at the end of the day we'll come back to looking at the next lesson. In our next lesson, please guys, we understand that we're going to look at implicit differentiation. In our next lesson, we'll be looking at implicit differentiation. See you guys then. Stay tuned, connected to Daniel Math Academy. Follow, like, and share our videos on Daniel Math Academy at Facebook, Daniel Math Academy, YouTube, Daniel Math Academy, and Instagram, Daniel Math Academy. Alright guys, see you guys in the next lesson. Implicit function.